temperatures rising and climate change already imminent, it is urgent that we adapt our cities and our rural areas to a new reality, where extreme rainfall is part of the norm. In this battle, reliable and valid data is the foundation of humanity's arsenal. And with the tTEM system, we have been given a new weapon. This area near Horsens in central Denmark region is one of many which anticipate increased precipitation. The tTEM, Towed Transient Electromagnetic Method, provides a full 3D mapping of the subsurface with a depth range of 0 to 70 meters, thus giving geologists and geophysicists a new and crucial tool for analyzing and planning.
We don't know exactly what is below our feet here at the nearest subsurface, down to maybe 30 meters. That is what is very important here. With this system, we are now able to see a lot of details in the subsurface, and those details are needed in order to make proper models of the flow of the groundwater in the subsurface.
The tTEM is easy to deploy, managed by a field crew of 2 persons. The system consists of a receiver and a transmitter, both made from non-conductive materials and towed by an all-terrain vehicle.
And the way the instrument works is that you send out a current in this 2x4 meter loop that's on sledges. You can see the small transmitter wire here, the red one here, 2x4 meter. And then we induce an electromagnetic field in the ground. It will decay, and the rate of decay is dependent on the resistivity of the soil. And that decay is measured in the receiver coil, which is the white one, approximately 8 meters behind.
Sledge runners make it possible to run it on rough terrain, such as farm fields.
By using an ATV to tow the system, we can map up to 250 hectares per day. This is quite unique and new, and you don't find any other methods that are capable of doing that in the world.
The tTEM makes a number of electromagnetic soundings. These are then transformed into easy-to-read images to be displayed on the screen.
What we're looking at here is the data that we have collected in the field, the tTEM data. We can translate those images to where we can find groundwater and where we do not have any groundwater in the area.
tTEM was developed by the EU-funded Interreg project Topsoil, together with Innovations Fund Denmark. Topsoil is a partnership consisting of 24 partners from 5 countries, aimed at exploring how the topsoil layers can play a part in solving future water challenges.
The geology is very complex, so we need the information of the geology to find out how the groundwater flow and the behavior of the groundwater is in that area, in order to see where we can expect groundwater flooding in the future in a changed climate.
In handling this challenge, the tTEM is a unique and effective tool, but the system has proven to be extremely versatile. The Aarhus University Geophysics Department, who owns and operates the equipment, is experiencing high demand from all around the globe. From the US, where the system, mounted on an inflatable device and thus renamed FLOTEM, helped local authorities map the soil layers of the Mississippi River. To the Arctic, where the system on this assignment, called SNOWTEM, helped the local authorities locate a missing engine part lost in the ice by an Air France aircraft due to an in-flight engine failure. The tTEM system is still evolving. The Topsoil partnership testing and exploring new ways to apply the technology. There is plenty to do. Climate change affects all of us, and climate adaptation based on knowledge of the soil layers will be a necessity in the future in construction, mining, agriculture, nature preservation, and in planning for new homes. tTEM is towing all of us into that future.